fantastic. I'm going to stand down here because the people I'm going to call up eventually in this session, I want them to have the stage versus me. I'm here to tee things up, but I want to have a little fun with it. First, just by introduction, I'm sorry?
Here we go, I said.
Oh, yes. Oh, it's all downhill from here, Eric, yes. Just a quick introduction, Simon Jacobson. I work for Gartner. Many of you know us for the Magic Quadrants. I've never written one, nor do I intend to do so. But what I'm going to share with us today is a different way of looking at the technology piece. And I want to frame it out with, first of all, I'm not a video game player. I'm really horrible at it, but something that I think we all can relate to at some point. So let me ask a question of who plays Wordle? Who plays Candy Crush or has at least one game on their phone? Without in-app purchases. I think we're all afraid to indict ourselves, but the point is, at some point in our lives, video games have impacted us somehow. And there's a lot of parallels that we can learn from the video game industry. And this isn't a when worlds collide or intent to act nostalgic and go down that path, but it's more of we've seen things evolve in lockstep, improved graphics. Some of you might still have this, but the graphics have changed. The graphics have gotten much better in terms of sophistication, in terms of how we can render and use data. We've also started to see the form factor change. Yes, you'll still have people at the equipment, but now you can start to interact differently, have all the information at your fingertips, and the vision of the future in terms of how we're going to use data is wonderful, but reality is a little different. It was interesting to see in the slides to talk about interoperability. It's there in the marketing literature, but it's not always there in reality. So it comes to the question of what must be true. And if we're going to back into what must be true, let's take a step back to 1985. That is when Nintendo sold its first console in the US. Now, it was pointed out to me yesterday, this is a different console than the first one, but at the same time, there's only so much copyright that you're allowed to get through. But the point is, with Nintendo or with any of these consoles at the time, is interoperability was proprietary. If you want to have a game or play the game Duck Hunt where you needed a fake pistol, or any of the other things that you can buy with Nintendo, say for Olympics where you needed the mat. Okay, I'm admitting I might have played some games growing up. The point is you had to buy the Nintendo licensed accessories. The only true interoperability perhaps was how you integrated it with the TVs, whether you had an RCA, a Magnavox, a Sony, or a Panasonic. The integration scenarios were only then different, but the actual value you got from the console was proprietary. And if you broaden this out a little, video games were never designed for interoperability. You can never take a PlayStation and an Atari and have them work together. Jonathan pointed out a whole bunch of other games to me yesterday in terms of ColecoVision and really brought me back to hanging out with my cousins. But the point is, we never designed these for interoperability. And if we look at the system architecture that some companies live with, and for some of you, this might be a simplification. This is designed to move data from box to box, not really looking at data from the point of a workflow. And now we add in all of the potentials that we can do, all of the different add-ons, whether it's multiple gateways at the edge to get different pieces of data, where we're going to experiment with generative AI. This is a level of complexity that only surfaces the challenges of interoperability. So, like the video game industry, how we access and how we engage with information has changed, and also how we monetize it. We've gone from the arcade in the bowling alley to hanging out at a friend's house and multiple games to now you can do this anywhere, which is, I asked the question about Candy Crush, Wordle, and many other games some of you might be engaging with now if I can't hold your attention. But the point is, you can do this anywhere. And as we move to the right, Xbox 360, where you can download games. The fact that Apple and Google, with their app stores, you can download, you can consume. Or as we talk about with app stores from providers, or the catalogs of SMIPs, you can start to consume information and interact with it almost anywhere. So let's come back to the question of what must be true. First, the positive. 83% of organizations, and this is from our most recent smart manufacturing study, 83% of organizations believe that smart manufacturing will improve competitiveness. Another 83% believe that, look, this is going to increase. Our spend will go up in the next 2 years, and this is up from 76% 2 years ago. We have the money to spend. That's not the issue. But when companies go to spend the money, here comes the challenge. 84% of organizations in this study, as you can see, it's not a meager N size, integration is the most substantial challenge. And I can tell you the list of challenges we had, integration is above process reengineering. It's above access to skills. It's above having the available budget. This is the biggest constraint. So if we come now to what must be true, what we're going to walk through in this next part of the session are a series of showcases and demos to give you all exposure to what is true, what can we do right now in terms of interoperability, in terms of accessing and connecting data. And to start that, I want to call up Jonathan Wise. Everyone's heard from him already, but I want to hear from him again to show us at the detailed level some of the cool stuff you can do with the platform.
Thanks. Y'all will be sick of hearing from me by the end of the day. That's me again. I want to start here. This is the short version of the workshop I gave yesterday. And I think the opening kind of assertion here is that the state of manufacturing information platforms is largely hierarchical and largely informed by a 1990s standard called ISA 95. ISA 95 is a living standard. Its most recent draft was just this year. So it's by no means dead or archaic, but the implementations that we largely rely on originate back to that original standard. And they largely have not evolved or kept up with the pace of technology change in other ecosystems. We have work to do, and it involves, at a minimum, breaking out of this thinking that all of the data that we collect has to be attached solely to something in this hierarchy. I'm actually not advocating for the removal of the hierarchy, but I am pushing on this constraint that all of our manufacturing data sources are only useful, only available if they can be mapped into a level in this hierarchy. Our software architectures are designed this way, our data access is designed this way, and this kind of artificial hierarchical construct has limited our thinking in software development in this space. We often think about equipment data sources. It's a good place to start because equipment is tangible. You can touch it, you can think about it, you can look at the data that comes off of it, and it has a natural mapping place into this hierarchy. The reality of this hierarchy is that we have lots of different data sources. We need business systems data, we need employee training data, we need supplier data, we need material data, we need job data. We need all of these things. And while there are places that we affix them, the Purdue model, which is paired with ISA 95 that has governed how we've made software since I was in college, follows this flow of sort of an upward roll where this data is added in layers. What if I told you that properly implemented ISA 95 looks like this? This isn't a hierarchy. There's probably a hierarchy in here. Like I said, we're not disposing of the hierarchy. But there are so many more points of data and so many more relationships in manufacturing data that go unexploited, that are undiscoverable, because we've limited our thinking and our software development to this sort of rigid hierarchical approach. Manufacturing data is full of these implicit and explicit relationships. And smart manufacturing platforms need to evolve to the point where they can preserve, follow, provide, change these relationships as manufacturing is happening, as both data and materials and people are flowing through a manufacturing operation. If this is a view of a single enterprise that is expanding their thinking to a graph beyond a hierarchy, we have to expand our thinking even more and understand that our supply chains are complex webs or graphs of interrelationships as well. This same thinking or change in thinking that needs to happen at the plant level, at the equipment level, at the enterprise level, needs to expand to the supply chain if we're ever going to have any hope of leveraging AI to solve supply chain constraints, to solve supply chain problems. You've heard me talk already today about profiles. This is a simple view of a graph, and from our perspective, the graph is informed by the profile. The profile gives structure to an object in the graph. There's a couple of different kinds of language we might use to talk about graph theory. The simplest one in my mind is that these objects are called nodes, and the lines between nodes are called edges. Those edges are the relationships. We can pick up any node and we can yank it to the top, and something like a hierarchy will cascade out from it. But importantly, we can pivot this whole graph and make a different thing the center of the universe. At any time, we can traverse this graph and explore those relationships. One of the organizations that has helped create and define these profiles that inform the definition of a node in a graph is the European Machine Builders Association, VDMA. This is an example of a profile that, if you look closely, is itself a graph. Our graphs aren't just these big pictures. Our graphs are also the small pictures. A proper information model needs to capture multiple kinds of relationships inside each node in our graph. So a graph is like an onion where we can peel back the layers and find new insights by following those relationships between what we would call strongly typed objects. We've worked with VDMA, with the OPC Foundation, with the 3 major cloud providers to build infrastructure to make these profiles more discoverable and accessible. CESMII's cloud library is downstream from the OPC Foundation cloud library. CESMII members, and actually anyone, since it's open source, can also run private cloud libraries where they set the internal standards for their namespace using this standard definition of an information model, what we would call a profile. Importantly, vendors can also consume this cloud library through a free and open API. I talked earlier about an API for data access. This is an API for profile access. It's a way to search for profiles that are applicable, download them into your software, and use those as templates for objects in your software. One of those integrations that's new and really exciting is Inductive Automation's Ignition platform. Starting in 8.3, this will be built into the product, the ability to go fetch a profile and use it as a UDT, but they've also backported it through their exchange into 8.1, so you can start now standardizing your templates based on these profiles. This is a really important step because one of the places people start an object-based thinking is at the HMI SCADA level. These objects need to be used throughout. To Tony's point earlier, each software provider can give us a piece in a recipe, but manufacturers need to build their own recipe out of interoperable parts. Those interoperable parts have to be available globally because no manufacturer is an island. We need to be able to interoperate our data and our software out of parts made from global contributions. We're going to talk next about some of those global contributions, but before we do, I want to give you a bit of a decoder ring. We have some terminology that hopefully you're fairly familiar with. There's some other terminology that we need to understand when we start interoperating globally. What we call a smart manufacturing profile is in its first part an OPC UA node set. The node set, a set of nodes, is usually offered in a format that is based on XML called the node set 2 XML. So sometimes you will hear profiles and node sets used interchangeably. I say in its first part, profiles actually had multiple goals. A complementary effort to profiles has been the asset administration shell. Asset administration shell is a container format. It can contain many different kinds of data. It can contain product data, diagrams, user manuals, carbon impact documents, a wide variety of things. But one of the things that can be inside an asset administration shell is what they call a submodel template. A submodel template is a profile. It is a definition of the data that can be found, in this case, inside an asset administration shell. We've had interoperability with those submodel templates for the past few years, but recently, through global harmonization efforts, the specific submodel template format that they were using has been supplanted by the UA node set format. So we now have global agreement that we will define our information models using a node set. If your software or the software you want to buy from a vendor can't hydrate or import a template from a node set, your software is 10 years behind already. It needs to catch up. This is the global interoperable format for defining information models that we call an SM profile. A second goal of SM profiles was to provide the mapping from unstructured data sources to the structure defined by the profile. I called it in the original documents I wrote like 5 years ago, Profiles Part 2. It was something I hoped to get to. Again, the international effort here has saved the day with a format called the Web of Things format. Web of Things is a JSON format that allows us to map unstructured data using an unstructured protocol, such as Modbus, into the structured format dictated by the profile. I would call it Profile Part 2, except Web of Things is a cooler name. We have good progress on adoption of this binding or mapping format, and that's going to become kind of the next required adoption for international interoperability. The reason this is important, in the US, we're thinking deep and hard about improving efficiency and energy. In Europe, they are preparing for regulation. The digital product passport is an implementation of an asset administration shell to describe a finished good. A specific digital product passport that is going to be required very soon is called the battery passport. And if you ship an EV battery in Europe, you must provide a battery passport using this standard format. It's not a consideration, it's not a future innovation, it is going to become a requirement. So if US manufacturers want to interoperate with Europe, increasingly we will have to adopt standards for defining the structure of our data and sharing that data across supply chains. Final definition, and I have negative time on this, really briefly on unified namespace, because it does play nicely into this. In computing, a namespace is a set of terms and it's usually given a label. Really brief anecdote. My name is Jonathan, and if you call me John, I'll correct you and say it's Jonathan, because at my first job, my boss's name was John, and the team took to calling me Little John, which was completely unacceptable. So I now insist on Jonathan. Little John is a namespace identifier. It was a way that humans differentiated one John from another, okay? This is a namespace. Within a namespace, I have an identifier that groups those symbols together so I know the context of their use. An address space, then, is a collection of these namespaces and the instance objects that are made out of them, okay? Unified should mean brought together, combined, or united, or involving several people, organizations, or countries that all work together. I think that's a great definition, and I rarely see it in UNS projects because the unification tends to be one team's unification, or at best, one company's unification. We can't proceed this way if we can't unify at least some of our data across the globe. It doesn't mean there aren't going to be internal specializations and specifications, but the data that we need to interoperate on has to be unified by more than just me and a couple of my friends, or a group of people I found on LinkedIn. I want to invite Doug to show, I'm not going to show, how all of this can work together in the current smart manufacturing interoperability platform. And when Doug's done, we're going to have a couple other folks come up and show how those same concepts are being used across the globe. So, Doug, you're up next.
Take care of the audios that the AV. So that we're on the right thing. Jonathan's going to need just a couple of minutes here so that you can actually see my screen. So I'll start back to way. First of all, what an incredible honor it is to be here watching the 7-year dream of CESMII and the 12-year dream of our colleagues in Europe and Germany coming together with velocity and with speed. This is amazing to see. As 7 years ago, when we started talking about profiles, people were fighting. When we started talking about supply chain data exchange, everyone was confused. And what's happening today is we're seeing a simplification of ideas built around a number of extraordinary simple concepts. And these will address that 87% problem that everybody agrees with, that the biggest cost is the integration of software systems. So this is an extraordinary time. And yes, I can see my screen. I like it. Let's take a look. So we spoke briefly about the importance to be able to not only create profiles, but the ability to share them. The tool that I'm showing over here is the CESMII Cloud Library, in which there are currently just under 200 profiles. Some are incredible, others not so much. We're working really hard to help you tell the difference and to be able to find them. Profiles apply to the entire problem space. They're essential, as Erich from Microsoft will share shortly, for supply chain data exchange. They're essential for connecting machines, and they're essential for creating those graphs that we spoke about earlier. We're connected to CNC machines right here in this facility. Let's take a look at how that happens. It uses a base profile created by CESMII, and that was created on the back of several of the CESMII-sponsored projects. What I'm going to do is I'm just going to briefly bring up a process layout, which is showing a graph of a set of interconnected machines. And I just want you to see that this is showing how materials can move between machines, one of the many possible relationships. And notice the fact that there's a single entry going to the chassis press in this particular case. And what I'm going to do quickly is just walk through the process of importing a library into the first implementation of the SMIP. So to do that from my personal version of the SMIP, which can be on-premise or in the cloud, I click on a user interface to allow me to import profiles, and here I can discover, navigate, and find profiles. What I want to do in this particular case is let's go and look for the CNC base profile, which is one of the few that has been published as a community project by CESMII. We can look at the details. It tells us that it brings in information about CNC machines and I'm going to go ahead and import this profile. So it shows me the various types that exist, and I'll go ahead and import the profile into the system. I'm now going to quickly jump back to my tool that I use for creating the graphs and the graphs that Jonathan referred to a little bit earlier. And what we've done now is we've got the ability to create CNC machine instances. And what I'm going to do quickly is take advantage of the next thing that Jonathan did, which was to tell us how they can be automatically wired and connected to data. So I'm going to take that CNC machine, I'm going to cheat here a little bit, and I'm going to run a little bit of automation that will allow us to not only create an instance of a CNC machine, but physically connect it to the data. If I go back to the process layout that I was showing earlier, that is showing the can-feed relationships between the equipment in the facility, and I refresh it, you will see that the CNC machine got added automatically to feed the chassis press. So not only now am I pressing data, but the bearings that are being machined by that CNC machine are being introduced into that process flow, which shows one of the many, many relationships that one can have. And I can drop back and I can say, show me that instance of that CNC machine in the system. Here it is. It has the full structure that came in from the profile that includes the axes and the spindles, etc. And eventually, if I navigate down through this model, I get to a specific spindle. And if we look at the spindle, we'll see that it has attributes defined on it. And if I go to the embedded, and this particular machine that we connected to is a little sparse in data, so I will go down and I will go to the load rate, and I will click on that, and we will see that data is flowing from the machine that was just connected. This is the promise of interoperability. A definition of equipment that was unknown to the platform, inserted into a graph that physically represents your operations and connect as a standard, and connected to data as a standard. This is vitally important and the basis for what we do. Jonathan.
So this is what we've been working on with our membership. I want to invite Erich and Dominik, who represent different organizations, but for our purposes are representing Europe, and the interoperability that we've been working on with them on the exact same concepts, harmonizing compatible and helpful efforts internationally. All right. If you can start sharing.
All right. So thank you very much, Jonathan. I'm going to show two concepts today.
Start sharing.
Yeah, that's what I'm working on.
It's that one. Doug's still sharing.
Doug's still sharing. Okay. So let me share. Okay. So now you should be able to see it. And I got my own mic as well. So Jonathan already mentioned Web of Things as a W3C standard. Why is Web of Things important? Well, as it turns out, all industrial connectivity software that we use today has its own proprietary configuration interface, both from a UI perspective and from a programmable interface perspective. And that causes integration pain, that causes extra effort for cloud vendors like Microsoft, but also, as I found out, by many, many manufacturers that use several different connectivity software. So pretty much all connectivity software that we use today to connect assets use OPCOA already for the data plane. And I thought, well, why can't we also use OPCOA for the control plane? So we created a working group inside the OPC Foundation called the What Connectivity Working Group. We created a specification that basically standardizes in a very simple way how to configure industrial connectivity software. And I'm happy to announce that next week at Smart Production Solutions, we will see the first implementations of this interface in products. We, of course, provided a reference implementation called UA Edge Translator to open source the OPC Foundation, because any working group in the OPC Foundation also needs to provide at least 2 implementations to prove out the concept. And this one is available through MIT license, so you can just use it as a reference. So what does that look like? Well, I'll show you. So here's a tool that I wrote that basically uses this new interface. And maybe I'll show you what a WAT file looks like first, so you can see. So as Jonathan mentioned, it's just a JSON file, but most importantly, it has all the tags that a particular asset defines and exposes provided in it or described in it. And it can also contain the mapping to things like OPC UA in the file itself. So everything is contained in the file, even how to access the data. Can you now hear me? Yeah. OK, great. Even how you access the data. So down here, for example, this is a Siemens energy meter. And down here, you can see that it is a Modbus device, and it has a holding register where you can read the voltage between live 1 and neutral connected to this particular energy meter. So the entire information is contained in the file, and Siemens and others have committed to providing these WAT files, just like they're providing PDFs today, which have all the information about that particular asset in it, and which is great. As it turns out, we can also use things like ChatGPT to generate these WAT files automatically. So, you know, with the latest GPT 4.0 large language model, we can get to 90–95% accuracy in actually generating those files completely automatically, even if you don't have them at hand, which I think is pretty cool. But anyway, so here's the interface. So all you need to do is provide the WAT file, and then it will access this new interface on, in this case, UA Edge Translator, which I happen to have running here on my laptop. There it is. Of course, it's containerized. Containers are so convenient when it comes to deploying software, let me tell you. And then all I need to do is hit send. It will then send the WAT file through this new interface to the Edge Translator and onboard this particular energy meter. Now, I don't have the energy meter connected, so I'm currently simulating the interface to the energy meter, so it's just a simulation. But the mapping has now occurred. You can see it has been configured successfully. So now I can just go and connect to this particular Edge Translator instance, right? And if I connect to it, I can see we're connected to it now. And down here, we have the definition of the energy meter. It says it's a Modbus. PAC 4200 is the model number and the serial number. All of this is integrated in the WAT file. And here you have all the tags mapped to OPC UA, including the smart manufacturing profile. And that's important. So in the file itself.
Can I make a summary statement about what just happened there?
Yeah, in a minute, right? So right here, you can see that we're also loading smart manufacturing profiles, and we're loading them into the OPC UA server. So both the profile is used and the WAT file is used. Go for it.
This was a device that was not compliant with any profile.
Right.
The WAT file loaded the mapping that allowed it to become compliant. So when Erich says asset onboarding, he means asset modernization.
Thank you for that summary. Yeah, that's fantastic. So one other thing I wanted to show you is the data exchange when it comes to supply chain and using that in a standardized fashion. So one of the things, and I just need to find my presentation here real quick. One of the things that we discussed yesterday was the asset administration shell and how it can be used to load smart manufacturing profiles, which is a new thing. So we've made that agreement with folks like the IDTA and the OPC Foundation. So now these smart manufacturing profiles can be loaded into an asset admin shell to standardize data exchange along a manufacturing supply chain. And like Jonathan mentioned, smart manufacturing profiles are based on OPC-UA node set files. So I will show you now how that actually looks like. So here is a demonstrator that we showed last year as the CESMII annual member meeting in South Tech. And we modeled a product carbon footprint for a roll of paper that the Northern State University, I believe it was, let me just open this, North Carolina State University. So they have a pulp and paper machine, and we modeled this particular product carbon footprint using the acid admin shell technology. But now for the first time, we can also use smart manufacturing profiles with this. So here is a OPC-UA editor, which of course can be used to edit a smart manufacturing profile. And I've done just that. I've modeled the exact same acid admin shell information using this particular editor. So you can see the carbon footprint here. If I open this up, you'll see scope 1, 2, and 3 emissions and so on. And then I can export this as a node set file. Like Jonathan said, its node set file is just a file format for smart manufacturing profile. And then load this into the acid admin shell, which I will do right here. So I can just add a node set file. So I just need to find it. And then I'll open it. It loads it into the acid admin shell, which we can see here. And now there it is. If I expand this, you can see that it has the exact same information, the product carbon footprint and so on, in this acid admin shell. So for the first time, we can use smart manufacturing profiles not just to onboard assets and to bring them into a consistent data format, but we can also use those smart manufacturing profiles and all the infrastructure that CESMII have created over the last few years to standardize data exchange along a manufacturing supply chain for things like reporting on carbon footprint of goods sold to a particular customer. Thank you very much.
Let me dive into right away. You need to digest that. I would like to start with thank you. I really take pride and honor that John and his team, so Jonathan on the forefront, Doug, where's Doug, Mark, and many more, Haresh, since I would still say 2017 early, really try to align. Interoperability needs to be global. And we had so many deep dive presentations now, Erich, Jonathan, I will not repeat that again. But there is no regional supply chain. Yeah, with some SMEs around the corner, but all supply chains are global. And that was really the visionary understanding of the great leadership of John that you really dived into that and we collaborate. I'm totally aware that companies have proprietary solutions and it will maintain. There are always orders and special areas and sectors where you need that. But in addition, we now have interoperable systems and they are made for automation and for non-Excel or PDF email attachment processes. And if we have that thinking, and I'm the greatest Excel lover, but it's not for our shop floor. So, and this will help us in a unified, standardized way to communicate without losing the business to another guy and having full control of the data. You don't open your, how do you say there, your door. No, you control, someone can request data and you control what you provide. These are the mechanisms. And in the machine, in the shop floor and the machine level, OPC-UA, and towards the business up, CESMII, SMP, RS, and now you realize we need to demonstrate that. Where can I ask questions? And we have different levels. We have the level of strategy, John, on one hand, and then technology implementation. So we need several levels to be able to answer questions. We need to demonstrate that it works and that we walk the, someone said today, I love that, walk the talk. Yes, we walk the talk since 70. This year, just in Hanover, we had that wonderful battery passport. It was a totally joint European-US made, basically. By the way, not French and not German. It was a French company that even, there was close to no German inside, but fair enough. And now we really want to, the next page, I will not repeat that again. We had that yesterday and we have 1 minute left for me. Where's the second page? Oh, I don't know.
I think it got dropped.
Fine, totally, I work on that. Let's demonstrate that next year also. Yeah, this is exactly what we have. If you allow me.
Really briefly.
Yeah, go ahead.
This is an asset administration shell. Eviden was the French company that provided an API for it. So we loaded the battery passport asset administration shell, pulled out the submodel template, which is the profile by any other name, and then we're able to instantly map the data from the battery passport into the smart manufacturing interoperability platform because we had agreed on the information model between the two. Importantly, the API was Eviden's, so call back to earlier. We also need standard APIs. We're working on that together as well.
That's very important.
But it starts with this kernel of common understanding of the data.
And it was not half a year and $1 million investment. It was weeks or days. Well, these are the experts of the experts, but still.
Three days.
Yeah,
Three days with two pieces of software that had never seen each other before.
Exactly. And we have these organizations like CESMII or Platform Industrie 4.0, IMX in Europe, where you then find experts that will support you. And this is why demonstration is so important. Let's also, one level up, we have that data space, data ecosystem thing, IMX. Japan is in the room. Nakashima-san, would you be so kind and wait? This guy is
He's coming next.
He's next.
Yep.
So this IMX thing will handle and organize that, and we demonstrate jointly with Japan, with Europe, with the United States. That would be my final word.
Thank you.
Thank you, Jonathan.
All right, then I'd like to invite our International Manufacturing-X friends up. Thomas, Mark, Nakashima-san.
Yes, so yes, the mic is working perfectly, and Mark and Nakashima-san come with me on stage, and I will promise to make it super short because a lot of information was transferred before. You have heard from Jim about trends and drivers, what are driving us as industry. You have heard from Jonathan, it's a little John I learned, sorry for this, about interoperability technologies, what is needed. You have seen from Erich and from Dominik some kind of examples how in doing this, how in using this. And you know, we want to make it super short how we are doing this, how we are bringing the different dots, the different topics together in a, let's say, in a structured way internationally. And that's what our International Manufacturing-X is about, what we are driving together. And maybe one comment, I'm from Siemens, you know, but today I'm standing here as, let's say, driving this together with the friends, I have to say, this international cooperation. And I'm really happy, and maybe you're smelling this, and now again, coming back to Siemens, when you're looking what different technologies are needed, what network is needed, nobody can achieve this alone. You have heard from Andrew, you have to go out of the four walls of your shop floor and to look to the left, to the right. And therefore, we are really proud to have a part of the CESMII community, really to address this together. And now I hand over to Mark after these words to speak a little bit about, and I will look for the...
Great, thank you very much. And I have to say that John invited me to come here and said, the dress is business casual, and since there's a lot of artificial intelligence, I thought I would try the black leather jacket look, since that's the new business casual in the US. So one might ask, you look at CESMII as it stood up, and I was involved a lot in sort of the original formulation of CESMII 1.0, and really done a great job, I will say, as a US public-private partnership focused on this issue of smart manufacturing and standing that up. We're also traveling around the country a lot looking at that, and realizing there are hundreds of thousands of workers in the United States whose paycheck they come home from a factory that might be named BMW or Toyota or Honda or Kia or Bosch. What does this wind up meaning? And often it's a case where even the data and the decision-making authority about what's designed, what's built, and the connected supply chains are already international. So just a recognition that it's not a question of as we go to supply chains and we create them internationally, the US manufacturing sector is already international. So with that in mind, talking to John about this is a couple of years ago, as people are suggesting, we need some forum where CESMII can communicate with organizations that are working in countries elsewhere doing similar work like this, where under this theme of interoperability, it starts with us listening to each other. How do we have a framework where we can listen to each other? And in doing that, as CESMII is solving its solutions, it's not stovepiped, it's interoperable. It moves across with that. So handing this off to our colleagues from Japan.
Thank you very much. My name is Kazuo Nakashima from RRI, Japan. RRI is an organization, the industrial association where manufacturers and also robotics-related company got together. We have around 400 of the member companies. And as you see, we are part of the IMX, and also even though the Manufacturing-X, the name itself started from Germany. However, IMX or Manufacturing-X itself, the concept is already the global, the sharing the concept. And we started the July last year, the preliminary meeting. And also the October last year, starting from Japan, but also in United States or many the other locations in the world, we spreading out the concept. And now the February this year, we had the kickoff meeting in Paris. And now here with the CESMII, the annual meeting, we are very happy to have the kind of the progress of the IMEX discussion, and also together with the CESMII's the many innovative ideas. So we are so happy, and we are ready to move forward.
And only to conclude how we are doing this, and you mentioned also to listen to each other and to hear. I think the first column you see here, the box on the right, this was our top level proceeding or task which we're doing, really to hearing what is available, what is needed, what we can do, which we can learn for each other. I think this attitude aspect, really to have it openly, to address the challenges which we have, and to look and to hear what is needed in regions or also in different verticals, coming from industry and speaking about discrete or process industry, there are sometimes also slight differences. To understand this is the first topic. Second issue is to look what are the infrastructure available. Doug mentioned, for example, this SM Profiles application platform. Fine, we have to look how we can make it interoperable, how we are doing this. And last but not least, and that's key, let's say, really, and coming back to especially to Jonathan's presentation, really to look how we can look about what are the standards, the interoperability standards which we can influence, not to define, influence together. I can say, I'm a vice president of the OPC Foundation, where we really need this information, what we do to achieve this together. But keep in mind, listening to each other, open, respecting each other, looking what are in the region needed or available, look what are the interoperability topics which we can together achieve. And only to mention, you have also here one person with Nakashima-san, who's also from the ISC Data Space Smart Manufacturing Ad Hoc Working Group. Hopefully I explained it correctly. And this is also the channel where we can together influence for us, because at the end we want to create impact. Many thanks, and many thanks to being here.
Real quickly, and Thomas also, I think, pulled me aside and said, which acronym did you actually use there? And I really just want to take this moment to say how happy it is to see as public-private partnerships under the entire Manufacturing USA banner have come up, the idea of having companies come together and having interoperating on these technology issues, I think that's the way we wind up continuing to move forward on competitiveness, productivity, and keep growing.